Hello, everyone. Welcome to today's webinar, Why CIOs Must Rethink Their Enterprise Incident Response. Before we dive into the presentation, let's review a few housekeeping items so you know how to participate in today's event. If you have a question at any time during this webinar, please submit it using the Questions tab located on your webinar player. Your question will be addressed during the Q&A session at the end of the presentation. At the end, please take a moment to rate the presentation and provide us some feedback by taking a short survey at the end. And finally, a recorded version of this presentation will be available within the next few days, and an email will be sent to you with a link to the recording. So feel free to share it with your friends and colleagues who were not able to join today's event. Now, I would like to introduce our speakers for today's event, especially our two featured guests from Forrester. Will McKeon-White works as a researcher on Forrester's infrastructure and operations team, focusing on modern service delivery. His research helps enterprises understand and capitalize on advances in processes and technologies for more effective IT and business service delivery, including enterprise service management and IT service management, and the use of chat ops and chatbot capabilities to create a better help desk, speed up incident resolution, and IT team effectiveness. Also joining Will is Charles Betts. He is a Forrester's lead ops analyst serving infrastructure and operations professionals globally. In this role, he covers continuous deployment and release automation, incident management, and emerging topics such as containers and chaos engineering. He also covers the transformation of traditional IT operations organizations into next-generation digital service organizations. He retains an interest in enterprise service management topics, areas such as service portfolio management, service catalog, IT asset management, application discovery and dependency mapping, configuration management, and CMDB, as well as industry frameworks like ITIL, IT4IT, and COBIT. Also joining Will and Charles is Vincent Jeffrey. He is a Senior Director of Product Marketing at Everbridge with a focus on IT service alerting, cross-team collaboration, and process orchestration. He has over 18 years of experience in the IT operations and service management space, with expertise in critical communications, IT service alerting, application performance management, IT process, runbook, and workload automation. Vincent also has international experience with work in Europe and in North America. Now, without further ado, I will hand things over to you, Will.
Excellent. Thank you so much, Shirley. Hi, everybody. This is the voice of Will McKeon-White, researcher at Forrester. And without any more introductions, let's hop right in. So this is what Charlie, Vincent, and I will be talking over in our short hour together today, hitting on what's wrong with incident management, what needs to change, and how to start going about this in your organization. So today, everyone has an incident management process, usually looking something like this. Relatively standard in most organizations, the response protocol facilitates communication, creation of responding groups, and troubleshooting. The specifics of the process steps depend on each incident and org, but more or less, this is the plan that organizations adhere to. And what this plan doesn't show, however, is that most of the stages, sub-steps, and handoffs between the steps are, for the most part, all still manual. From identifying the fact that something's going wrong, to alerting stakeholders, to establishing a resolution team, to investigating the issue, to pushing a change into a system. Each step has tools to assist, but today the incident management process as a whole is disjointed and ad hoc. Well, you can get really good at manual incident management, you'll face a constant headwind from the usual issues, which are pretty well known today, but are still relatively tolerated. And starting with silos. Today, most organizations do face silos interrupting collaboration. Despite a fairly constant messaging of silos are bad and disrupt work, they are a fact of life. Organization by specialization is a straightforward and well-established way to organize an enterprise, and are difficult to shake up after they're entrenched. So why are they bad in the context of incident resolution? Well, when you're dealing with something going wrong in a complex distributed system, you need collaboration from relevant persons on infrastructure, operations, development, security, and everything else. In manual incident response, just due to their nature, silos hamper identification of key individuals, create territoriality, interrupt lines of communication, create strange lines of ownership, and generally delay figuring out what the heart of any given problem is, all of which exert extra time and effort to overcome. And this is, my apologies. And this is exemplified by intergroup tribal knowledge, where certain things are just known to one group but impossible to know for another. In some instances, something's going haywire that the infrastructure team can't figure out may be a result of a known error that one dev team has already figured out. If no one knows that a specific dev team has the answer and the dev team is unaware that the thing they know how to solve is going wrong, that's time wasted and business impacted. This is just a fact of life for organizations with the majority manual incident response, where taking the time to formalize this tribal knowledge can provide difficult, as it takes away time from solving immediate problems, creating a perpetual cycle of more manual work, which is something that nobody wants. So despite being identified as a problem for collaborative work for years now, silos still add complexity into manual incident response, interrupting communication, delaying knowledge transfers, and requiring you to add a host of hidden weird factors and conditions into your resolution plan. There we go. And adding further pain, distributed toolchains create systems of information to manually correlate. Well, organizations usually have the necessary tools to identify and assist in incident management. They're usually distributed across the organization and disconnected. For example, you may have a network monitoring tool that will help identify an as-of-yet unexplained network slowdown between two core application components living in a distributed infrastructure system. However, the tools live with the networking team, and that hasn't been connected to your enterprise systems team for central monitoring software, which in turn hasn't been connected to the point monitoring solution the DevOps group acquired, who is currently experiencing an issue with their application due to that core system dependency that they don't have insight into, and are such looking in the wrong direction for resolving the issue. These three tools all have the information relevant to the incident, but are just disconnected from each other and residing in different teams, resulting in the need for manual communication and the correlation of these important bits of information. And these two issues just further contribute to the confusion of incident management and help fuel the revolving door of incidents, where people are continuously brought into the resolution bridge who may or may not be able to resolve an issue, only to realize that the incident isn't related to them at all. When your incident management system is relying on human identification of key individuals and application owners, you're relying on mind maps and disjointed documentation. And this type of system, getting the right people responding quickly, is increasingly a matter of luck above all else. And if your responders don't know who's relevant to a resolution and don't know where the info they need is, you're adding noise to the resolution process, delaying a fix and causing frustration in an already tense environment. And these are just the issues manual incident management faces today. Beyond all of these basic known problems, we live in a world where incidents are rapidly growing in complexity for a variety of reasons, from the evolution of application to geopolitical mechanics, making it even harder for you to restore your systems and meet your SLAs. And one such complicating factor is environmental sprawl in distributed environments. We're going through another period of environmental proliferation, with the number of application architectures and abstractions still ever growing. From on-prem to on-prem virtualized to cloud infrastructure as a service to SaaS applications to containerized to serverless, your technology environment is becoming ever more complex and sprawling, architecturally and geographically. Consequence of this, when something goes wrong, your org is dependent on an increasing number of fields of expertise, disciplines, geographic cooperation, and service providers. This is further compounded with traditional issue of infrastructure failure, from network outages to dying servers, all the way up to increasing natural disasters and similar catastrophic failures. We're faced with what feels like an ever-growing list of randomly occurring threats, which by and large can't be avoided. Coupled with stack sprawl, you're going to be experiencing issues across broader areas. If a hurricane is coming for your data center, or lightning struck and one of your generators isn't sending power right, or wildfires are burning towards you, quite simply, you have to deal with that. You can take precautions to mitigate the damage, but these aren't issues that human mitigation factors can entirely avoid. And with the changing unpredictable environment and the unpredictable nature of infrastructure failure, these random catastrophic events will impact your business and your employees. Well, these are not new issues faced. The sheer number of possible failures and ever-growing catastrophic potential introduce complexity and uncertainty into incident management that must be accounted for. Procedures must be put in place to mitigate such damage, like geographic failovers, well-documented physical incident responses to keep your employees safe, and a management strategy for such threats. And on a somewhat massively less dramatic, yet nonetheless impactful end, automation and known error shrinkage and application lifecycle shrinkage are changing our understandings of quote-unquote easy incidents. And this is a quieter trend generated by the increasing pace of automation and application evolution, where it used to be that major applications would be updated once or twice a year. Known errors would arise, issues where workarounds are well known and just had to be communicated. With the increasing pace of application releases, the lifetime of this known error is shrinking dramatically. And while these known errors do still exist, we're finding that systems of automation are able to handle this resolution or apply a fix without human intervention. Increasingly, when we're called in to assist in the resolution of an incident, the issue hasn't been seen before, and it's caused by a unique combination of things going wrong. And some organizations are already feeling this increase in seeing MTTR go up as a result of this. And this is just so far things going wrong randomly. This hasn't even factored in human threat elements yet. With the increasing availability and sophistication of cyber weapons and those that make them, cyber attacks are on the rise, and many organizations have been caught completely off guard. While there is a recognition for demand for increased cybersecurity and better security practices, some organizations are still just totally unprepared for this and may not even know where to begin or are unable to get meaningful change made in the organization. Many are vulnerable to these sorts of attacks, and these cyber attacks are becoming lethal, like targeting medical facilities with ransomware to prevent the treatment of patients, or explicitly weaponized malware like Tritium, compromising safety systems and oil and gas refineries that could weaponize critical infrastructure. And finally, international legislation is affecting how incident management has historically been done, either with accelerated acknowledgement of suffering from an attack, disclosing information was lost or compromised, and generally requiring a better understanding of what went wrong with more communication externally to your organization. While in some respects, this legislation is simply requiring more due diligence from organizations with respect to the customers, is requiring a maturation of the process, extending incident management beyond just the resolution of the thing going wrong. And put simply, all of these are creating an environment where incidents are becoming more complex, the consequences more dire, the expectations for resolution are rising, and how it's been done with the known issues and disconnection isn't going to scale in the face of this. Despite all of this, though, at its core, incident management hasn't changed, and the core elements that your process has been designed to address remain the same. First, in a given incident, you need to identify there's something going wrong and narrow down the symptoms. Ideally, this is done before customers are impacted. From there, you assemble a team to investigate the issue and its cause. You need a cross-functional team to identify contributing factors to a given incident, to work together in a cooperative fashion, sharing expertise and combining areas of knowledge. And finally, after you've identified what's broken, more or less what's causing it, you need to go into a given system and implement the resolution. Repeat in the loop as needed until the thing that's hurting your business is resolved. This core set of requirements for incident management hasn't changed. What will need to change is how you go about fulfilling each of these steps. And so how does this need to evolve in your organization? So the first shift you must take is facilitating and encouraging more intergroup communication on an ongoing basis. And this may be done through tools, team structure, and incentives. Prioritize tools that allow for collaborative work, not simply handoffs. Incident management isn't transactional, but emergent, and should facilitate the tracking of the moving targets that come with incident work. And these tools should be able to capture what was changed, what was tested, and how the fix was implemented, and how to avoid this issue in the future. With the compounding complexity, one-off resolutions that aren't recorded won't scale. After actions are increasingly meaningful. And team structure, similarly, must reflect this collaborative work. You may not be able or interested in integrated product teams, but dedicated silos are increasingly counterproductive. Quite simply, technology doesn't operate in silos. Introducing or enforcing barriers during periods of required collaboration impacts your time to resolution and your business. One model for this evolution is changing from a role-based team to an outcome or mission-based team and adjusting your incentives to prioritize accomplishment of an objective than a role adherence or fulfillment. And this encourages greater flexibility in how objectives are met. Some ways this is done through cross-training in skills, ambassadors or champions to certain disciplines, reducing barrier-forming process gates, and adopting a non-transactional collaborative work platforms. And Charlie can speak to more of what he's been seeing in this area.
Yeah, absolutely. Well, and just tremendous insights that you're sharing here. Very, very well done. So, of course, when we talk about a role-based team to a mission-based team, we're talking about product teams. We're talking about the transition from functional silos to product organizations. And this is a transition that a lot of you, I think, are going to you're going to be nodding your heads. We are aware that organizations across the board are looking at new operating models. They are looking at bringing in diverse sets of staff into teams of usually no more than 8 people. And those teams have the variety of skills needed to deliver the mission, to deliver the objective. And this is absolutely a trend that is in full swing across the industry. We're seeing trends away from the functional silos, the specialists who love to bat the tickets around like a game of badminton. Emphasis on the word bad, because you wind up with bad outcomes when people are playing ticket tennis like that. And so we are focusing much more on bring the people together who you need to solve the issue. One of the key enablers for that, of course, is a chat platform. And, of course, Slack, Microsoft Teams, take your pick. But that more directly synchronous interaction gets you beyond that conversation. How many times have we heard people say, have you updated the ticket? Well, when somebody says that, and if I were on a conference bridge and I heard that nowadays, I certainly heard it enough back in the day, but if I heard it nowadays, I would say, this is a broken operating model. Nobody should be asking stressed out digital professionals who are trying their hardest to wrap their heads around some complex issue they've never seen before. Nobody should be asking them if they've updated the ticket lately. I'm sorry, that's just not how it should work. And this is why we need new platforms, new technologies, new techniques. Will, if you could advance for me.
Of course. And yep, thank you, Charlie. And so chances are you already have some of these connected tools today where the monitoring solution you have access to will feed into an Excel spreadsheet or has been wired together through an API, or you have them integrated into your ITSM tool. But your tools can't really stop there. Beyond this connection, you still have to manually correlate data, bring in other sources of truth, find and reference knowledge articles, look up organizational charts, and take care of a number of different manual steps despite having quote-unquote connected tools. Not only should you continuously connect the tools containing systems of record through APIs and integrations into the systems of work, but some of these tools should be doing this manual work for you. Hook in a CD pipeline to facilitate post-incident changes you push into the system. Or when it comes to updating a ticket, have a bot do that in your Slack channel. Leverage modern incident management systems, AIOps platforms, and the like to better correlate data and immediately you gain a more complete understanding of your environment and points of failure across disparate systems. And Charlie, I think you can add a little bit more here.
Well, it's true that back in the day, one of my badges of honor or shame, depending on how you look at it, was that I was an enterprise architect for a long time. And I think that the number one recommendation here is that you need an enterprise architecture. You need to determine how your tools are going to stitch together. And you need that just as much for the business of IT as you need it for the business of banking, the business of insurance, the business of retail, the business of manufacturing. The business of IT, and I know that there's concerns about IT as a business. I'm not suggesting that. But at the end of the day, you do need an integrated architecture for your dev and ops tools, especially as we move into this DevOps world of increasing release frequency. It's all got to act as one coherent system that enables a fast cadence of highly stable releases. And you don't get there, if the tools don't talk to each other.
And just to add a little bit to that, even if you don't have plans to adopt that in your organization right now, you're still going to be affected by that. As we were talking about earlier with the known application lifecycle shrinkage, your tools that you use are being updated more frequently and things can go wrong in a quicker cadence. And so whether you like to or not, the whole trend of DevOps will be impacting you and your organization in some fashion. So to get ahead of that, finally and somewhat paradoxically, as soon as this slide can shift for me, there we go, you should begin to shift from a reactive to a proactive stance through your tooling and priorities. Part of this proactivity is choosing tools for the ability to analyze infrastructure and application trends to predict common preventable issues so these don't impact you down the line. An increasing number of tools are able to perform predictive capacity management, for example, in addition to other fixes, and are capable of providing suggestions for resolution that can be executed at a click of a button and don't require long investigatory periods as to what is actually going wrong. And similarly, increasingly monitoring and management tools are adopting an approach of opinionated infrastructure, and that are routinely updated with best practice configurations to avoid known issues or security vulnerabilities and can automatically enforce compliance across a distributed infrastructure. And looking out part of the day for resolution of known problems and routine maintenance. If your organization doesn't mark out this time for proactive or reinforcing work, you'll never have the adequate resources to respond to and recover from failures. Proactive work is required to improve your systems of automation and test your planned contingencies. If you have backups or failovers, but you don't test them, you don't have a reliable recovery strategy. If you're not prioritizing this type of basic proactive work, even when you do have to spend a significant amount of time firefighting, you'll be facing constant attrition and the fires will really never go out. And Charlie, I think you had a bit on this as well.
Well, what comes to mind, of course, is the rise of chaos engineering. Chaos engineering is the ultimate proactive, I think, safety practice here. And it's got its origins in the Netflix idea of Chaos Monkey. Actually, Netflix, I think, has retired Chaos Monkey and has moved on to new approaches, but they're still taking this basic approach that you cannot understand your system effectively in pre-production environments. All of that complexity that Will articulated so very well at the start of this webinar means that the only truth is production. And it used to be the worst thing in the world for a team to be accused of testing in production. I'm telling you, folks, we're heading into a world where you have no choice. And that is absolutely going to change operating models and governance and expectations. You have to look at how do you limit blast radius. But I think the leading organizations, and Target Corporation, for example, is on the record. They've presented in public about how they're moving in this direction. A big part of it is you've got to stress your production systems. You've got to deliberately inject error into production systems. Now, of course, it's dependent on the sensitivity of the workload. I am not suggesting, unleashing a horde of chaos monkeys on critical, civil infrastructure. We've got to do this smartly, but you could start attending conferences if you want to hear more about this and figure out how to do it effectively. So I'm going to leave it with that. I will say, however, in the interest of plugging our DevOps predictions, it's one of the major DevOps predictions we made this year, that chaos engineering would become an accepted control strategy at the board level in large organizations, or will we start to be recommended by major audit partners. We'll see if my prediction comes true, but I'm fairly optimistic.
And just to add an example of how seriously some folks are taking this today, recently ran across something called, I think it was Thanos Cluster, where it was a tool that would actually randomly kill half of your containers in your environment just to test if you could actually recover from that type of massive critical failure. And the Thanos is just a reference to the Marvel character and the recent popular series of movies, but it provides a pretty good example of how seriously some organizations are willing to take this, where they can just try killing half of what is actively running just to make sure they can recover from that failure. But collaboration, integration, and proactivity are kind of nice and all, but so aside from the analysts kind of pontificating at the moment, how do you go about actually implementing these ideas in your organization? How do you enact this change? Well, we've found a few models provide us with an idea of how to start in your organization. And as Charlie had mentioned earlier, related to sort of Slack and Microsoft Teams channels, one core element of achieving these goals is providing your employees with the tools to do their job and to encourage collaboration. Collaboration isn't something that should be done only when you're facing a crisis, and chat ops, actually chat operations, provides a model for this sort of work. It's a relatively simple concept using a collaborative team-based chat platform like Slack or Microsoft Teams as this center of work, using integrations to backend systems or chatbots. And these chatbots can actually take action in these backend systems. And so if they provide a mechanism for not only communication, but making changes in systems, you have a way to, or making changes and retrieve information from systems, you have a way to rapidly contextualize work and increase visibility between disparate systems. So in a chat ops structure, instead of 10 different responders staring at their own different screens and tools, they can rapidly and effortlessly bring this information they're looking at into a shared location, just into a single screen that everybody can see. And further, you can cut down on the number of tools you're leveraging through integrated monitoring suites, monitoring aggregators, and modern incident management tools. The less manual correlation of data you have to do, the faster you can identify sources of failure and remedy the outage, which is increasingly critical in the world of distributed and interdependent systems. And how do you actually go about splitting the proactive and reactive responsibilities? In this respect, we found that Google's SRE model provides a pretty good point of reference, even if you don't intend to adopt SREs in your organization. The basics that it lays out when it comes to this are extremely valuable for any given organization. So while everybody wants to get more preventative work done, the common refrain is, we just don't have the time. But proactive work can't be an afterthought. And in this day and age, it has to be a priority. The model provides one mechanism for this, specifically putting firm partitions between on-call and engineering work. These strict partitions are key for reducing context switching between this proactive and reactive, giving practitioners the time they need to focus on what they're doing, like automation or testing backup systems, instead of being routinely distracted by another thing catching fire in the corner. While these ratios of on-call to engineering time should vary depending on the context of your business, ensuring that this proactive work not only has time marked out to it, but there are goals related to it is critical for increasing your organization's resiliency. And to take another note out of Google's SRE model and from many other organizations, blameless postmortems are critical for understanding what went wrong and how to avoid that failure in the future. Instead of simply fixing the incident and moving on or identifying the fault of an individual or team, incidents are symptomatic of a failure of systems, not one thing. Blameless postmortems provide your teams with a roadmap for what to improve or for new security measures needed. One of my favorite examples of this is a new developer was brought on board to an organization and was told to follow the training materials for testing. Somehow, the training materials had pointers to the production environment, and one of the tasks he was given to was to delete a test environment, or was to delete the database in a test environment. But because of the way that the onboarding materials was set up, it actually ended with the production credentials being entered and the actual production database being deleted by this first day developer just going through the training materials. And instead of actively going about and rectifying this massive oversight, the organization fired him and likely will continue to suffer from the same actions. Don't be that organization who doesn't learn from its mistakes. If you're simply just moving on, you're losing the knowledge gained from resolution. And if you're looking for someone to pin the blame on, you've opened yourself to another person making the same mistake again. And each failure are the instructions for avoiding such an issue again. And that's critical in the face of the growing complexity. And stakeholders in the business side of the house should participate in this postmortem. How can you refine, ensure communication? How do you meet the SLAs from a business standpoint and make sure that you're checking all the boxes? And then resilience engineering, which Charlie can go into a bit more detail on.
Absolutely. So this is one of the exciting areas that we're seeing, I think, some real progress on. And I have to first, note that resilience engineering, if you Google it, you're going to get some kind of academic hits here. But, I teach part-time as well as being a forester analyst, and I don't think academia and theory are bad things. I think we need them, and I think that human society is at its strongest when we actually develop theories, but then bring them strongly into contact with practice. And that's what's happening in resilience engineering. It's got a firm grounding in science of cognitive psychology and human factors and ergonomics. That's why there's a person there with sensors on their scalp and a picture of a brain there. But then on the other side, it looks at very much the application of why did the human being choose to do this at this particular critical moment in time that then resulted in this tragic situation that the National Transportation Safety Board, the NTSB, has to come and investigate. Or why, how are we dealing with the stress? Those gentlemen on the bottom right there, that's the Unified Incident Command for the Deepwater Horizon, the oil platform in the Gulf of Mexico that caught fire. So all of this comes together, and guess what? It's some of the same people who are involved in all of this. And now, thanks to some thought leaders like John Allspaw, we're starting to see digital professionals coming in and getting much more involved and engaged with this broader topic of resilience engineering. I think that chaos engineering and site reliability engineering eventually roll up under this. It's very exciting, and I've got a lot of passion around it. Very interested in talking to anybody offline. If you're starting to engage with resilience engineering or even questioning what it's about, please do drop us a note. So I think with that, we're probably coming up on time here. So I want to be sure Everbridge has some time, and I'll leave it at that.
Yeah, thank you very much, Charlie. And I think that we all agree on the 3 points which you and Will described very elegantly. One is that incidents are becoming more and more complex. They are becoming also more and more frequent. And we see that there's more and more regulation. And I believe that anyone who's listening to us today either know about GDPR or is already tasked with complying with these regulations or with the regulations that are coming up in the United States as well. And we also agreed that today incidents have to be resolved even faster than ever before. 2, critical incidents can originate from anywhere. We talked a lot about IT complexity, IT failures leading to business issues. Like you mentioned also, Will, in one of your slides, cyber attacks is rising, as we all know, with impact not only on IT teams, but on the entire enterprise, as well as any external events, such as, like you also mentioned before, hurricanes, or natural disasters, which can have a direct impact on business operations. So the question really becomes three organizations. I think we all agree that organizations cannot keep responding to critical incidents which are impacting their business the same way over and over again and expect different results, right? So I guess you understand what definition I'm referring to here. So the question here really becomes, what we need to change? Do you need to change to streamline your incident management processes, given the large number of tools that your different teams are already using? And that's, what also Will and Charlie covered earlier. And there's something that I also want to highlight here is it's not only the technology and the processes. We need to take account of the people, and people have to be in the center. Again, whenever these issues happen, we need to know who needs to be actively involved in the resolutions. We need to know who needs to be kept informed. And again, that might be outside of IT. Your legal department, if in case of a cyber attack, I would recommend that they are involved in the incident response process. Who are the customers which are being impacted by this event, right? By this incident, and what are we telling those customers? So, like you said, we need to take into account, and we need to implement a unified incident response frameworks and methodology. So, what we do at Everbridge, we work with organizations of different sizes across almost all industries. And what we found is that the main challenge that organizations face is really to get to a point where they can become predictable and meet their SLAs consistently with every single critical incident, whatever the nature of the incident. And this usually is due to a lack of common communications rules across the teams, across the organization. We talked about cross-team collaboration, and we see a lack of effective cross-team collaboration in many, many cases. Again, resolving a major incident is going to require that we involve people from different teams, from different maybe countries, continents, on different time zones, people who are not used to work together, people who may even don't know each other, right? So how do we get a hold of those people? How do we get them to collaborate? We have the tools. We have the chat operations tool, the chat ops tools, but how do we get them to collaborate on the same channel? And the third weakness that we see is the orchestration. And Charlie, you talked about it, orchestration between the different activities that are going to be required to restore the service, right? So whether we work in silos or not, there are different activities that are going to be performed by different teams at different time, and we need to make sure that this is well orchestrated so we can resolve the incident in a timely manner. Now, let's see if I can run the slides from here. Yes. So I was just saying that communication, collaborations, and orchestration are the key elements that need to drive the enterprise incident response process. So now, digging deeper into the actual process. And I like to summarize the end-to-end incident response process in 5 phases. The first one is detect. Businesses, organizations have to be made aware that, hey, there we have an issue. We are dealing with an incident. That's the detect phase. That's where we're going to know about the issue, do the classification, categorization, prioritization of the incident. From this, we'll have to gather this cross-team together, team of responders together, so that they can start the investigation, put together a remediation plan, and last but not least, give it a test and make sure that whatever we've done to remediate the incident has actually restored the service, right? So when we look at this, the good news is most of companies, I would say, have already invested a lot in monitoring tools so that they can get better at proactively detecting issues even before end users find out that there is an issue with the application or the service that they are using. Again, you want to become proactive versus reactive. You don't want customers to call into your service desk to report an issue. And technology today helps with this. AI ops, we talked about AI ops, all the monitoring tools. We see more and more predictive, but also cognitive automation that's going to help with this. 2, we also see that most organizations have already invested in enterprise ticketing system. So you would use those systems to categorize, prioritize, and collect the information related to an incident, right? And to Charlie's point, you also don't want this to become a showstopper or bottleneck. You don't want to have this piece of technology here drive the entire incident resolution process. It is a repository where we're going to collect information from the different tools, from the different teams, so that for the post-mortem review, we'll have all the information stored in one place. But where we see that companies fall short is with the next step, which is what we refer to as the incident response per se, right? This is the most time-consuming step in the process, and it consists in identifying and communicating and engaging with the right teams of responders so that they can start collaborating earlier in the process. There are different surveys and research that show that on average, without automation, this step here, rally and respond, takes an average of 60 minutes today. So that's the first issue. The second is stakeholders. We need to find a way to automatically identify the stakeholders and keep them updated during the entire resolution. And last but not least, the impacted customers. We need to know what's going on. So like we said, for IT, for the IT people, for the responders, we need to find a way to bring them together on the collaboration tools that you may be already using. Should they be Slack, WebEx, or Microsoft Teams? Again, if you need me to be involved on a restoration call, don't ping me on Slack if it's 2 a.m. Now, you still need to find a way to get me to connect to my device and join the team that's going to respond to the incident. So like I said, many reports and studies have showed that how incident response automation can help organizations become more efficient, more effective, and more predictable. And that combination of on-call schedule, communication automation, collaboration tools, and we talked about chat ops earlier, that are going to involve not only the IT responders or the responders, but also the stakeholders and the impacted customers. Again, at the end of the day, we want to refrain customers or impacted customers to call into the service desk. And this is, as you can imagine, going to help us resolve incidents faster. Also surveys show that with automation, this step that consists in assembling the response teams and get them to collaborate on chat up channel, which was 60 minutes on average, with automation, you can get this metric down to 5 minutes or less. So again, that's giving 55 minutes back to the teams in case of a critical incident. So this is going to help us resolve faster, avoid induced cost to the business, and it is also going to increase people's accountability. No one's like to be, to be pinged and say, hey, you have to come and help us on this particular issue. So how do we make sure that when people receive a notification that they need to be involved, they actually will participate, right? And this is not going to be a notification or an email that's going to sit in an inbox for hours. So with that, I just wanted to give you my key takeaways from what I've learned and from working with large organizations and what I've learned working with analysts and specialists in this field is, yes, enterprise incident response is complex. Automation and tool integrations, the automation and integrations are two must-haves today if we want to cope with the complexity and if we want to be able to resolve incidents faster. And while we're doing this, the third takeaway will be that today technology exists. Yes, we have enterprise IT alerting solutions, AI ops solutions, incident response automation solutions. Now, we need to ensure that not only do they work together, but we don't want to forget the people. The people are key in any execution of incident response processes. And the people, again, are going to be the resolvers, the stakeholders, but also the key customers that we need to keep updated during the resolution. So if not done yet, you may want to have someone on your team review your current incident management process to see if the performance of your teams, the predictability of the process itself can be improved and can be improved by how much. And from this, you can make then make a business decision on whether or not it would make sense for your organization to invest in incident response automation. And with that, I think we have a few minutes for questions. So I'm going to turn it over to you, Shirley, to check if we have any questions.
Okay, great. Thank you, Vincent. So the first question that we got from the audience is, so Will, I think this question is probably directed at you. You mentioned mission-based teams. What does this mean?
That is an excellent question that Charlie and I can help answer. But so when it comes to a mission or outcome-based team, you are orienting what your team is supposed to be doing around the execution of a certain objective. And so whereas a lot of teams are a little bit oriented to this today, it's sort of more in here's your responsibilities and the fulfillment of stability, or this is what you are responsible for, instead of this is what you need to accomplish. And so I think, Charlie, you can probably provide a little bit more specific context around that.
Yeah. So, obviously, in a narrow sense, every team might have a mission. But what we're talking about is business outcomes. And the number one book I'd recommend right now is From Project to Product by Mick Kirsten. That I think is a good outline of what we mean. You could swap in product team structures. And there's a lot of discussion in the industry about moving to a more product-focused approach rather than just consolidating all the Java programmers, all the requirements analysts, all the testers, all the operations staff. Those are functional silos. And yes, they might have a mission or an outcome, but it's a pretty weak mission as far as the business is concerned. I mean, the business doesn't want, just code written. The business wants operable digital systems that are adding value and contributing to the bottom line. And that's more what we mean by an outcome or mission-based perspective.
Okay, great. Thank you. So another question for both of you. So how do you base goals off of proactive work?
Excellent question. And so when it comes to that sort of partition that we mentioned earlier between proactive and reactive work, instead of just having goals based on keeping systems alive, you should also be focusing on sort of automation goals. And have you networked together certain points? Have you made process improvements in the response to certain issue or in the response time? Can you do things faster or more resiliently than they are now? As well as, so have you actually taken the time to go about and start working on this proactive work that needs to be done? Have you actually tested these systems and start to build these small goals into the overall responsibility, as well as reducing the amount of time that folks are responsible for being on call actually within their within your end of year assessment? And that's sort of one of the main ways that we've seen this be implemented in organizations today. It does vary a little bit depending on the specifics, and so that you might have one system that you're working on one year and then another the next. But in general terms, that's how we've seen that done across the board.
Okay, great. So the next question, I believe this is for you, Vincent. Enterprise incident response is something everyone is concerned with, but it can be overwhelming to try to streamline all the processes at once. So what's the approach that you would recommend?
Yeah, it's a very interesting question. Yes. So yeah, agree with this. That can be overwhelming when you start considering all the different sources of critical events, right? Natural disasters, cybersecurity, IT failures, and trying to solve all these issues at once can seem difficult. So recommendation is, again, this is critical event management, and that covers different areas. So the first question you want to ask is, where do we start? Where do we want to start? Are we going to work with the chief security officer on the more of the physical areas? Are we going to work with the CIO on the digital incidents? Do we want to take an approach where we are going to also consider a cybersecurity and work with the chief information security officer? So first thing is try to find the best spot to start. Then the question you want to ask yourself is, what are the mission critical applications? What are the mission critical services for the company, for the business, right? And Charlie, you just talked about business outcomes. Yes, that's what matters. What is the business outcome? And if something goes wrong with the delivery of the service, what is going to be impacted? So start with your most critical, your most mission critical application or services. And a good way to start then is digging into your major incident management process today. What tools are we using? Do we have which are the product teams that need to be involved if something goes wrong with this application? What tools are they using? What chat ops tools are they using? How do we reach out to them? Who's going to be on call? What's going to be the rotation schedule? What if they're not available? What if they're on PTO? What if we need people from different locations, different time zones? How do we reach out to those people? What's going to be the communication rules? How are we sharing information across this team, this cross-functional team, to be more efficient? How do we communicate with the people who are impacted by the incident? Who else do we need to involve? If it's a cybersecurity issue, as you know, regulation now requires that we also report to external auditors and regulators, right? So what information will we be sharing? Who's going to approve this communication? What, and put in place all the different metrics that are going to have to be followed during the resolution. What is my SLA for this type of for a P1 or major incident on this particular application? And what if we are still not resolved after 2 hours? What if we are still not resolved or restored after 4 hours? What is going to be the escalation mechanism, and so on and so forth? So this is, the recommendation is, again, just to summarize, business outcomes. Think about business outcomes. Where should I spend more time to get the biggest return on my investment? Look at mission critical application, look at the underlying process and see where things can be improved in terms of communications, collaborations, and orchestration.
Okay, great. Thank you, Vincent. So I think we have time for one more question, and the question is, how do self-heal systems be part of the incident resolution framework? Will, can you comment on that?
That's a fun one.
I have some thoughts on that. So the history of IT infrastructure is the quest for self-healing, and this does not prevent systems from having incidents. Error-correcting random access memory has been a thing for a long time, right? It's a form of self-healing. But it's now sunk below the covers. You don't notice it. You just assume that the system's going to act in a certain way. But as we discuss in our work on the automation paradox, and got a recent paper out called Beware the Automation Paradox, whenever we come up with a technical innovation like a self-healing system, the human race does not sit back, kick back, sit in the shade with a pina colada. We exploit, we stretch the system, and in fact, this is a law that comes from resilience engineering. It's called Hollnagel's Law of Stretched Systems. Great, self-healing system. Let's put the pedal to the metal and let's see how far we can take this thing before it breaks. And so, yeah, great, we're going to have self-healing systems, but we have to look at them in this broader context.
And I would also just add a little bit to that. I think one of the more interesting self-healing mechanisms that we're seeing now is, I believe, the opinionated infrastructure that I mentioned earlier, and those are extraordinarily useful in reducing risk overall. And so making sure that your entire environment is effectively making sure that it's secure, making sure it has the latest patches, and reducing the number of random vulnerabilities that you can have if your infrastructure is poorly configured. And so it does help remove that avenue of threat as being a potential cause of outage or issue. However, it doesn't get rid of everything. And so it's most useful in terms of removing the potential for certain things going wrong. And I think that's, as Charlie said as well, that might cause some issues if we become over-reliant on that. However, we've already found that it can significantly improve organizations' resiliency just as a whole from simple clicks of a button.
Okay, well, great. Thank you, Will. Thank you, Charlie. Thank you, Vincent, for a great presentation today. Again, this presentation is recorded and available in the next few days. This concludes our presentation. Thank you, and have a good day, everyone.
Thank you.
Thank you.
Thank you very much.